A very warm welcome again. Now, continuing with the chapter, and we'll be studying the topic reactivity of acids and bases. Now, what neutralization actually is? HCl and NaOH associate in the aqueous solutions. We know this. Addition of NaOH solution to HCl solution is like adding a large concentration of OH minus ions to a large concentration of H plus ions. As we had seen before, that HCl is the strong acid, whereas NaOH is a strong base. Now you can see, well, when we add these things, what happens? However, water dissociates into H plus and OH minus ions to a very small extent. Therefore, when mixing, the excess OH minus ions combine with the excess H plus ions to form H2O molecules, which mix with the solvent water. This change can be represented by the ionic equation shown as follows: H plus Cl minus plus Na, that is HCl plus NaOH, is we can say. So it gives Na plus Cl minus, where it is this H plus and OH minus gets combined and gives us H2O, and this is what neutralization is called. Now we'll be continuing with the reaction of acids and metals. The reaction of acids with metals is determined by the strength and the concentration of the acid, and also by the reactivity of the metal and the temperature. It is easy to bring about the reaction of a dilute solution of strong acids with moderately reactive metals at normal temperature. Now, in this figure, you can see the burning of H2 with an explosion. We have test tube in here with the cork with the bubbles of H2O form, dilute HCl and Mg, that is magnesium ribbon. Magnesium metals react with dilute hydrochloric acid and an inflammable gas. Hydrogen is formed. During this reaction, the reactive metals displaces hydrogen from the acid to release its hydrogen gas, and you can say that Cl, that is chlorine, is remained. At the same time, the metal is covered into basic radical, which combines with the acidic radical to form from the acid to form the salt. Third point is reaction of acids with oxides of metals. The chemical formula for red oxide is Fe, that is the iron oxide, Fe2O3. You have to remember all the formulas and what is released. You have to remember this even. The water insoluble red oxide reacts with HCl to produce a water soluble salt, FeCl3. This gives a yellowish color to the water. The following chemical equation can be written for this chemical change: FeO3, when mixed with HCl, it gives FeCl3, that is the chlorine is mixed out with the iron present, that is Fe, and as we know, water is formed. Starting with what electrolysis is, here is some sort of activity given to you all. What you have to do is, you have to take a solution of 1 gram copper, that is Cu, copper sulfate, CuSO4, in 50 ml water in a 100 ml capacity beaker. Beaker is a container sort of thing, which is made up of glass, porcelain glass. Use a thick plate of copper as anode and a carbon rod as cathode. Arrange the apparatus as shown in the figure and pass an electric current through the circuit for some time. Now what happens with zinc? In the above activity, copper appears to have deposited on the portion of the cathode immersed in the solution. What is seen that copper is attracted on cathode. Cu atoms are formed when electrons coming out from the cathode combine with the Cu++ ions, 2+ ions. A deposit of the copper appeared on the cathode. Even though the Cu++ ions in the solution was used up in this manner, the color of the solution remained the same, because while electric current was on, electrons have removed from the Cu atoms of the anode and sent to the battery through the electric wire. The Cu++ ions formed in this manner entered the solution. In this way, decomposition of the solute in the solution took place due to the electric current. This is called electrolysis. Cathode reaction. What happens on cathode? As we had said, that copper get attracted on the cathode Cu2 plus 2 electron minus gives us Cu, the stable couple, whereas on anode what happens when the copper in the solid state get reacted with the anode, what happens is the original form which we had converted on the cathode reaction we found the same. These two ones are the same. Now we're moving with what electrolysis is. It is found in the above activity that the volume of the gas formed near the cathode is double that of the gas formed near the anode. Scientists have also shown that hydrogen gas is formed near the cathode and oxygen gas near the anode. From this, it is clear that electrolysis of water has taken place and its constituent elements have been released. The concerned cathode reactions are as follows. What happens when electrolysis happens? Cathode reaction, what happens on cathode when water, that is H2O, is dissociated? 2H2O plus 2 electrons, we get H2 plus 2OH minus, whereas on anode we get 2 molecules of H2O is formed as O2 plus 4H plus 4 electrons. This is all about chapter number 5, acids, base and